All right, hello. Our first lesson is powers and exponents. So let's listen to this description and see if we can kind of pick it apart and figure out what it's really saying. It says a product of like factors can be written in exponential form using an exponent and a base. So we know a product is the answer times 3. These are the like factors, and their product is 9. So a product of like factors can be written in exponential form. What does that mean? All that means is you have 3, since you're multiplying it by itself. 2 times, it's 3 to the second power. We use an exponent and a base. So a base is the number used as a factor. 3 is our base. And the exponent tells us how many times the base is used as a factor. So this is the important part for those exponents. So for example, we have 10 times 10. These are our factors. Written in exponent form would be 10 to the second power. Our 2 tells us we multiply that 10 by itself 2 times. And then there our 10 is called the base. We can read this 2 different ways, 10 to the second power or 10 squared. So whenever anything is to the second power, another way of saying that is squared. All right, let's take a closer look at powers. Powers are numbers expressed using exponents. For example, 100 is a power of 10 because it can be written as 10 to the second power. So let's take a look at all these. Any number with 0 as its exponent is always going to be equal to 1. No matter what that number is, it could be 5 to the 0 power. That equals 1. It could be 8 to the 0 power. That equals 1. 10 to the 0 power equals 1. 10 to the first power, standard form is simply 10. We're not taking it times anything. Okay? 10 to the second power, if we look at it in factor form, remember our exponent means multiply the base by itself that number of times. So 10 to the second power means 10 times 10, and when we multiply those together, its standard form is 100. 10 to the third power is 10 times 10 times 10, which is 1,000. 10 to the fourth power means we take 10 and multiply it by itself 4 times, and that would be 10,000. And finally, 10 to the fifth power means we take 10 and use it as a factor 5 times, because 5 is the exponent. And I am going to count out 5 zeros here because that's a pattern if we look back in one moment. 1, 2, 3, 4, 5. My comma goes after every 3, so that's 100,000. Let's take a look at these zeros. Notice 10 to the first power has 1 0. To the second power, 2 zeros. To the third power, 3 zeros. To the fourth power, 4 zeros, and to the fifth power, 5 zeros. So we can use that pattern to get those answers quickly. Let's take a look at the next page, and we're going to look at perfect squares. All right, numbers like 1, 4, 9, and 16 are called perfect squares because they are squares of whole numbers. So I'm going to show you a visual here. We have a square, and we know the characteristics of a square are they have all sides equal, all right angles. So if these sides were equal, and that was 1 square unit, its area would be 1 times 1, which is 1. This number here, 1, is called the perfect square number. Okay. The next perfect square number, if we had a square and it was 2 units on this side by 2 units on this side, and we wanted to find the area, we'd have a 2 by 2 square, and its area would be 4 square units. So 4 is our next perfect square number. Another visual, if we had a square and it was 3 square units on each side, and when I'm talking about those units, that means from here to here is 1 unit. Here to here is the second unit, and then here to here is the third unit. So straight across we have 3 units. So we have a 3 by 3 to find how many areas, how many square units are inside. 3 times 3 is 9. 9 is our next perfect square number. So let's take a look at all of these squared numbers. 1 to the second power means 1 times 1, which we know is 1. That's our perfect square. 2 to the second power, or 2 squared, is 2 times 2, which is 4. 3 to the second power, or 3 squared, is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. And 6 squared is 6 times 6, which is 36. And this list can go on and on. We can analyze it, find patterns. We'll do that later. What I would like you to do is get some practice. So write each product using an exponent. So I'll give you the first example. Since we have 3 sixes, we would write that base is 6 and the exponent is 3, 6 to the third power. The next section, write each power as a product of the same factor and then find its value. So a product of the same factor, I take that base 5 times 5 is 25, and that's its value. So go ahead and finish up on that, and we'll talk about it in class.